Okay, now you can see in the screen, this is the question. In the circuit shown, assume BJT with a beta value of 120 is operating in the active region. Now the question asks is what value of RB will result in a collector current of 0.8 milliampere. Okay, so that means we have to find the RB for a collector current of 0.8 milliampere. Now this question is based upon the transistor biasing concept and also region of transistor concept, because it has been said that the transistor is operating in the active region. Now whenever transistor is operating in the active region, then some sort of approximation we can assume. First approximation is, you can assume that whenever transistor is operating in the active region, the base emitter region, okay, the base emitter region should be in the forward bias direction, and the collector base region should be in the reverse bias direction. That means base emitter junction should be in forward bias and the collector base junction should be in reverse bias. Now this is the case of the active region operation. Now in the case of the active region, the two approximation is, we can approximate IC equal to beta IB. This is the relation between the IB and the IC. That relation we can use in the case whenever we assume the transistor in the active region, and also we can assume that the VB, base to emitter voltage, okay, so this is the base to emitter voltage. We can assume this is the base to emitter voltage should be in the 0.7 volt in the case of the NPN transistor. This is the NPN transistor, okay, so this is N, this is P, and this is N. Okay, so if we assume the NPN transistor, then these two approximation we can assume in the case of active region of the transistor. Okay, so the first approximation is IC equal to beta IB, we can assume in the active region, and VB equal to 0.7 volt. That is, if the VB equal to 0.7 volt, that means transistor should be in the active region. Now to solve the problem, these are the answer: 216 kilo ohm, 78 kilo ohm, 168 kilo ohm, and 113 kilo ohm. Okay, so what value of RB will result in a collector current of 0.8 milliampere with a beta value of 120, and the transistor is operating in the active region. Now this is a very simple problem. Just the two approximation you remember: IC equal to beta IB and VB equal to 0.7 volt. Now I have redrawn the circuit here. Okay, so okay, so this is the circuit. Here is the 12 volt, here is the 2 volt, and this is RB, and this is your RE 680 ohm. Now in the case of the transistor, when you are solving the transistor problem, you must remember that any resistance should be in kilo ohm and current should be in milliamps, and any voltage should be in volt. So that is the unit you must remember whenever you solving the problem in transistor, because you don't need to convert the unit to its base value, because whenever you take the resistance value in kilo ohm, current as milliampere, and voltage as volt, then you can get the value in this way. Okay, so this also you must remember whether you are trying to solve the problem in the case of the transistor biasing or the region of transistor. Okay, now if we apply KVL in this loop, okay, then this is the VI input voltage 2 volt, that 2 volt is equal to RB into IB current is flowing through it, this is the IB current, so this is IB into RB plus VB, this is base to emitter voltage, so this is 0.7 volt, I have assumed also in the first slide. Okay, this is 0.7 volt, and next this IE into RE. Okay, now in the case of IE, whenever in the transistor IE, you all of you know that this is, if this is your transistor, then this is the emitter, this is the base, this is the collector. Now we all of you know that the emitter current is equal to base current plus the collector current. Now this emitter current is the base current plus, we have assumed in the case of the active region, IC equal to beta IB. So IC equal to, this is your beta IB, So this is your beta, plus 1 into IB. Okay, so this is the value of IE we are interested in, so that we must put here IE equal to beta plus 1 into IB. Beta is equal to 120, so IE equal to 121 into IB. So that's value just we want to put here. Okay, so this is your 121 IB IE value, and if we just put, okay, so suppose if we just put 121 into IB equal to IC divided by beta, so IC divided by 120. Okay, so that is your value is IE value, and if we just replace IE with 0.8, then we get IE equal to 121 divided by 120 into 0.8, so 0.81, and also your IB equal to IC divided by beta, so IC equal to 0.8 milliampere divided by 120, so your IB equal to 0.8 divided by 120, so that means 0.0067 milliampere. Just put this value here. Okay, so 2.7, so 1.3 equal to RB into 0.0067 plus 0.81, all of this in 0.81 in milliampere, 0.0067 is milliampere, and so this is your milliampere, and whenever resistance is kilo ohm, so here 680 ohm. If you just convert this in kilo ohm, so 0.68 kilo ohm, so that's why 0.81 into 0.68. okay, so 0.68 into 0.68 is the value of your RE. okay, so you have to just multiply 0.81 into 0.68, so that will be your 0.5508, so 0.5508. if you just 1.3 minus 1.3 and divide it by 0.0067, okay, so then you get value almost equal to RB, almost equal to 112 kilo ohm. okay, and your nearest answer is 113 ohm. Actually if you just put this value in this way in the equation, that means 121 divided by 120 into 0.8 and 0.8 divided by 120 in this way, rather than writing this, if you just go on writing in this way, then you get the value exactly 113 kilo ohm. I have just made some approximated value here, that's why we are getting this value in the 112 kilo ohm. But if we just put this value in this way and finally calculated the result, then we must have get the value 113 kilo ohm. So your final result is 113 kilo ohm. Okay, thank you.